All right, let's look at some roof geometry here. So what I have is a hip roof. We're looking at it from the top, and these red lines indicate the very center of the beams. And we have our commons that come out at a 90-degree angle from the ridge. And notice this is a common as well. So we have a common here and we have a common here. They're identical. And then we've got our hip that comes out at exactly a 45-degree angle that's nestled in between the two commons. And it's crucial here to understand what triangle we're talking about. When we calculate the length of our common rafters and the length of our hip rafters, we're always using the width of the building. And what we learned with gable rafters is when you know your run here and the slope or the pitch of the roof, you can figure out the length of the diagonal, right? So that's represented by the green triangle. Hip rafters use that same building run, but the hip rafter has more geometry, I guess, more compound angles going on, that it not only has to go to the outside of the building, it has to rotate and travel along a 45-degree angle. And so that's represented by the blue triangle. Right? If you see the difference, the blue triangle, the run is much longer. Right? To go from the center of the building, it has a longer way to go. So it has a longer run than the common. The angle, or the overall slope, needs to plane in with the rest of the roof. But the common just comes out at a 90-degree angle. The hip comes out at a 45-degree angle, so it is a longer way to go to make it all the way out to the outside of the building. And this is crucial because when we lay out our commons, we go building run, pitch of the roof, and we can calculate the diagonal. That run is always based on 12 inches, 4 and 12, 6 and 12. The hip uses a different run. So the hip's run is based on 17. The pitch is the same. If this is a 4 and 12 roof, this would be a 4 and 12 common, but it would be a 4 and 17 hip. If this were a 6 and 12 common, this would be a 6 and 17 hip. The reason for that is if we go back to our right triangle and we're looking at this in top plan, if we have 12 inches along one side and 12 inches along the other side, the distance between those two sides, the hypotenuse, if you do the Pythagorean theorem, a squared plus b squared equals c squared, and then you take the square root of it all, you get 16.97, close enough for us to call it 17 inches. And everything in this hip here is a square. So all of these sides are the same length, where I'm tracing around with my cursor. So for every 1 foot of run in this direction, the hip has to make 17 inches of run to meet up to the same point. So this is why on your speed square, there's a second row of little hash marks for your hip and valley rafters rather than your commons. This is why if you use your Construction Master calculator, there's a hip valley button that you use. If you were going to use a framing square, rather than setting 4 and 12 on the tongue and the blade, you'd set 4 and 17 on the tongue and the blade to create this angle. But this is the key thing. You still use the width of the building. The difference is, rather than a 12-inch run, your hips use a 17-inch run. They have farther to go, but everything has to plane in. And all of the rafter tails should be in the same plane so that the fascia can get installed. All of the angles. You'd have sheathing coming across here, would land right in the middle of the hip. And I go into this in more detail in another video, but also when you install this hip, you're not worried about the very tippy top here. What you want is this right edge to plane in with this common and this left edge to plane in with that common, so that as you have sheathing coming over those two, they land on all the rafters. So this has nothing to do with your calculations or your cuts or anything. This has to do when it comes time to actually nail this hip in place. You want to flush both sides with the commons on either side.